Okay, here we have a problem where we have to find the nth term for a quadratic sequence. Now, there are two ways of doing this. There is the, let's say, the traditional way, and then there is an algebraic way. Okay, so first thing, let's remind ourselves. So the nth term means that each term, n is equal to 1, 2, 3, and 4. So n is just kind of our place in the sequence, or kind of page number counter. So what we do for both methods is we find the difference between our terms. So the difference of this is 4, difference of this is 6, difference of this is 8. That's the first difference. Now, if the first difference was the same, it would be a linear sequence. But as you can see, it's not. So then we take the second difference. The second difference between 4 and 6 is 2, difference between 6 and 8 is 2. That's the same. So that tells me this is a quadratic sequence, and there is an n squared term. Right, so now the traditional method is this. I'm going to draw a little grid. Okay, so now I know that my second difference is 2, and then what we do is we divide that second difference by 2. So that's going to give me 1, and that means there is 1 n squared. Okay, so now I write down what n squared is. So the first term, n is 1, 1 squared is 1. Second term, n is 2, 2 squared is 4, 3 squared is 9, 4 squared is 16. Now I'm going to subtract my n squared term from my sequence and see what I'm left with. So 7 take away 1, I've got 6. 11 take away 4, I've got 7. 17 take away 9, I've got 8. 25 take away 16, I have got 9. Right, so now this, as you can see, the difference between each term is 1. This is a linear sequence. So now I need to write the nth term for this part that is left. Okay, so that means basically it's going up by 1, so that means it's n. And for the first term, if n is 1, I need to add 5. For the second term, n is 2. If I add 5 to 2, I get 7. For the second term, n is 3. 3 plus 5 is 8. So this is n plus 5. So that means that my sequence is n squared, my 1, plus n plus 5, which is my 6. So this whole sequence is n squared plus n plus 5. That's kind of the traditional way of doing it. Okay, there is another way of doing it. Now we know that any quadratic sequence is a n squared plus b n plus c. Okay, so that means that the first term, when n is 1, is going to be 1 squared times a, which is 1a, plus 1 times b, which is b, plus c. The second term is going to be 2 squared times a, or 4a, plus 2 times b, plus c. The third term is going to be 3 squared, or 9a, plus 3b, plus c. And then we're going to have 16a plus 4b plus c. Okay, and that's how we can write that in terms of algebra. How does this help us? Well, if I look at my differences, okay, the difference between the first term and the second term is 3a plus 1b. Because I've gone from a to 4a, I've gone from b to 2b, but c is the same. So when I subtract them, I've got 3a plus b. Okay, and then if I think about this one, I've got 5a plus b. Okay, now how about the second difference? If I do the second difference, it's just 2a. So now let's look at that. So my first one here is A plus B plus C. My first difference is 3A plus B, and my second difference is 2A. Okay, and we saw from our example that A plus B plus C was 7. That was the first term in our sequence. The first difference was 4, and the second difference was 2. Okay, well you can see if I work in this direction, if 2A is 2, then A must be 1. If 3A plus B is 4 and A is 1, that's 3 plus B is 4, so B must be 1. A plus B plus C is 7, well A is 1 and B is 1, so C must be 5. So our quadratic sequence is n squared plus n plus 5, which is exactly what we found from the other method. Okay, now this method, this algebraic method is good, but it means you need to memorize these terms, the A plus B plus C, 3A plus B, and 2A.